All right, so for today, what we're going to do is work on a challenge problem for series circuits, as well as go over solving a parallel circuit. It's going to be a basic parallel circuit, but the next video is going to go over a challenge one. So what I did was I just went online and found the first series circuit that I could find that had missing elements to it, and I'm going to go through the steps of solving it. So if going to my computer, we have this circuit right here, which is also simplistic in nature, but what we see here is we have a resistor missing. We do not know the value. However, what we do know is the voltage total, the resistance for one of the resistors, and the current total. So let's just recreate that. And let me just swap over. So we have our voltage source. Here we go. That one was 12 volts. It goes over here, and now we have our first resistor. Now let me make that a little better. Our first resistor, and its value is going to be 2 ohms. And now we're going to have a little ammeter right here, and it's reading 1.5 amps. Now it goes down into our second resistor, and we do not know the value for that. And then it goes back to our voltage source. Okay, so first, before we get to work, let's just jot down what we have. We have VT, and we have IT. We're looking for RT, PT, which is power. All right, we're looking for VR1, VR2. We know what IR1 is. And we know what IR2 is. Well, we have R1, which is 2 ohms. Well, let's first write down what we're looking for. And we have R2. And then we have P1 and P2. Okay. And we're going to do it a little bit faster using a couple shortcuts. So, VT is 12 volts. That's given. R1 is 2 ohms. IT equals 1.5 amps. And that means IR2 and IR3 are going to be the same. All right. And now what we're looking for is VR1, VR2, RT, R2, and all of the power. So we can look at what we have and see that we have the voltage total and the current total. And going back to our little chart right here, I and R, we're looking for resistance. So let's just circle that in red. So like we did before, we're just going to cover it up. And if we divide our voltage by the current, we should be able to find the resistance total. So taking our voltage, which is 12 volts, and dividing that by 1.5, we should be able to get our resistance value. Taking out our calculators, we got 12 divided by 1.5 equals 8. 8 ohms. So that means our resistance total is going to be 8 ohms. And now, from this, we can find R2. We know that we have 2 resistors, and one of the resistors' values is 2 ohms. So we take our resistance total, RT, and subtract it by R1 to get our R2 value. So it's going to be 8 ohms minus 2 ohms, and it's going to be equal to 6 ohms for our R2 value. 6 ohms. All right, from then, we have enough value to find R1 and R2. So, going back to our little triangle here, call it a triangle because, boom, that's what it is. We're looking for VR1 and VR2. So let's get our cover in right here. So we need to multiply I times R. 1.5 times 2 and 1.5 times 6. So let's just show the operation. IR1 times R1, or it could be RT in this case because it's series, but let's just stick with IR1 and R1, is equal to VR1. And IR2 times R2 is equal to VR2. All right. So let's just substitute our values in. 1.5 amps multiplied by 2 ohms is equal to 3 volts. And 1.5 amps multiplied by 6 ohms, and just to make sure that's right, 1.5 times 6 is equal to 9 volts. So we have 3 and 9. And to double check our work, we know our voltage total is 12 volts. So the individual voltage values should add up to that. And we see 3 plus 9 is indeed equal to 12. So now all we need is to solve for PT, PR1, and PR2. So the way we do that is just like before. P is equal to I times V. So we just do it for each one. Or we could just, actually I'll do it like this. Let's find PR1 and PR2 and then add it up to find PT. So PR1 times I1, IR1 is equal to PR1. And made a little mistake there, is VR1. And VR2 times IR2 is equal to PR2. All right. So we know it's 3 volts times 1.5 amps equals, let's just get the calculator out to make sure we're right. 3 times 1.5 equals 4.5 watts. And R2 is going to be 9 volts times 1.5 amps. 1.5 times 9 is equal to 13.5 watts. All right, so that's going to be our values for P1 and P2. 13.5 watts and what was it again? 4.5 watts. So let's make a prediction on what PT is going to be. By adding 4.5 and 13.5, we're going to get 18 watts. So this is what I predict our power is going to be. But let's just do it the right way and take our 12 volts, which is VT, times 1.5 amps, which is IT, and see what that's equal to. It is indeed equal to 18 watts. So we are done here. All right. And even though we were missing a component, we were still able to solve for everything through, I guess, inadvertently solving for our individual resistor and then working back from there. So yeah, thank you everyone and have a good day.